Hi everyone, I'd like to welcome you along to our 10th Masterclass discussing how to build cool things in space. So today's class is going to be covering avatars. We had a couple of requests at last week's office hours to really sort of get into down and dirty with building custom avatars, specifically those that aren't actually built off our own base skeleton. And the other question we had that someone wanted to know the answer to was how to build custom avatars that can still interface with the existing clothing and other systems that are built into space. Now that's going to be a little bit more experimental. I have not tested this technique out. In theory it should work, but in practice we don't know. We'll have to follow up a little bit after next week just to confirm whether or not it did actually work in the end. But we'd like to get into that. And then the third thing I'd like to cover off is potentially physical attachments and those kinds of things that actually can sit on top of your avatar and animate on their own independently of the main avatar. Will depend a little bit on how much time we got to get into that one. But the first thing I had on today's agenda is actually creating non-human avatars. Now, Mary has been asking me to talk about how to do this for quite some time, so I thank you for your patience. So today we're actually going to rig this tiger, and the tiger is going to be set up as a custom avatar that can be worn and animated as you would expect it to be. Now, if we take a look at the model, and we'll just pull it up into the animator, just save this scene quickly. If we pull it up into the animator for the original model, we should be able to find that it is a generic rig. That means that it is not humanoid. It does not have the usual humanoid bones. In fact, if we look in at the object itself, you'll see that it's got its own little quadruped layout. Now, we're not necessarily restricted to quadrupeds or anything else. I have a spider which is available that is a fully octopedal motion controller complete with a whole bunch of animations. This one is just whatever's in the actual skeleton. It's been custom built for this animal. You don't need to sort of retroactively try and squish a humanoid into whatever shape you're looking for. You can just go with whatever you've got. So when we look at this one, we've got basically it's just set up as a generic animation on the animation import tab, so just make sure that one's ticked there. Otherwise everything's stock. You have got nothing to configure. Unlike humanoids, you can't adjust the animation rig and things after it's already brought in. The other thing you'll notice is that it's got a bunch of animations built into the object already. So if we go sort of into the walk and hit play, we'll see that we've actually got a walking animation in here that works pretty well. Likewise, there's the whole sort of rig that we need to set up. So, there's a couple of things involved in getting a custom avatar first set up, but the biggest and most complicated is getting an animation controller. So the animation controller is a sort of state machine. It defines how the character behaves when it receives certain inputs. So we might send an input to the character saying the player is moving forward. What the animation controller does is say, okay, well when they're moving forward it needs to be this animation, and when they move forward a little bit faster it should transition into a running animation. Those kinds of things are decided as part of a state machine. Now it's a lot more powerful than just simple state transitions. We actually have the ability to blend various nodes together, so we will actually blend our walk and our run together progressively over speed. So it won't sort of jump into a run. Instead, it'll sort of blend into a run as we go. So to begin with, we're just going to create a new animator controller. In fact, I'm going to base this off the existing one just to save us some time. So if you search around in the editor pack, there should be a player controller. There we go. So we've got this one. This one's built into the editor pack. You can find it if you just search for it, player controller. And I'll just move that to my directory. So now I've got our player controller. This will just serve as a base because it's got all the parameters up to begin with, and we'll talk about that in a second. So I'll just call this tiger controller. Now, when we open up the controller, you see this is our basic one that comes with the editor pack. Now, if you've looked at the animations inside the editor pack, they're pretty rubbish. That's because it's this basic animator. The full one that's in our main Unity player file is actually about 96 different states in all sorts of transitions, but unfortunately we've used a couple of copyrighted animations as part of our thing, so we can't actually distribute the full rig, which is why we've got this sort of cut down rig that's part of our editor packs. So the key is that there's an idle, and then everything's sort of blending off that. We're going to actually scrap all that and build our own from scratch in a second, but first thing I'd like to just draw your attention to is the input angles, horizontal, vertical, magnitude, all these kinds of things actually sort of are parameters that we feed into the controller at runtime. So you'll notice that they're numbers. Basically we will feed, for instance, in input angle, we'll feed a number that runs from -1 to 1, and that will actually be whether the player is walking or turning left or right. Likewise, we will feed the velocity of the character into the input magnitude. All those sorts of things will come into what we're doing. So the first thing we're going to do is we're just going to wipe out everything. I'm going to wipe out all of these guys, and we're going to start from scratch. So I'm going to create a new empty one, and this is just going to be called idle. It's going to be a very root node that we're going to sort of base everything off, and we're going to start dragging in animations. So I just need to find the animation that we're using. So this, if you just click on the avatar, you'll see that it'll point you back at the right model file. I just want to keep this one open while I quickly begin dragging things in and out. So I'm going to grab their animation, their idle animation. I'm going to grab the walks, walk back. I'm going to go jump. We're going to go run fast. And I think that is probably the level of animations. I guess while we fly, we might go with something silly, but we do need to sort of build in fly animations and things as well, unless there's no likelihood that the character will actually we'll reuse the run animation for that one. So we'll bring that in a second. Okay, so first things first, we're going to set up our idle. In fact, I'm just going to delete this idle because we've got one here. Let's bring that back to idle. Now we are going to transition in and out of the idle state based on whether nothing is happening as far as the input magnitude. So in fact, what I'll do is I'll create a blend machine. And this is going to be a basic blend tree. I might pull some of these animations in here. So a blend tree will pull together multiple animations based on various informations. We could actually rig almost all of this animation. Probably the jumping is the only one that won't sort of run through a blend tree. Normally we could have quite a few. We can actually nest these several levels deep. So what we would normally try to do, if you're building an optimal animation for a character, you will actually want to have turn left, turn right, and you want to have sort of walk, run, walk backwards, fly up, fly down, fly. Those are the core animations you sort of need to have in order to build a fully functional avatar. Now this one we're going to do a slightly more complex. We're going to do a 1D animation. We're just going to pull from the input magnitude. This is going to be our we would potentially use horizontal and vertical instead of input magnitude if we had left and right turning animations. We don't here. Actually, I think we've got strafe, so actually maybe we'll go this way. I'm going to actually create a new blend tree as well. So, add a blend tree here, so we can actually chain these together. So I'm actually going to do a strafe left and strafe right on this one. Let's create two motion fields. On this one. In fact, we might even go with 3, but hopefully. In fact, I'm going to add a third one. I'm going to go left to right. And I'm going to have the idle in here. Okay, now as we change the input angle, you'll see it's actually moving between the two animations. We hit play. See that it's going with the strafe right when we've got the input angle set to there, strafe left when it's there, and when it's 0, it's just sort of sitting there. Now this is the wrong parameter. We want to set this to the horizontal. That's going to be the left and right. So -1 to 1. So we will remove automated thresholds, and we will set that to -1, 0, 1. And now we've got the blend sort of set to -1. It'll move left. With 1, it'll move right. Now this is probably going to be a bit slow because it's going to be in conjunction with our other various animations going on, but we'll just add this all into the mix. So I might speed this up. So I'll set this animation speed to might be a bit funky, but there we go. That's our first blend tree handled. Now, this one's going to be on the vertical, so that's going to happen if you're not holding down a forward key. We're going to add another blend tree, and this blend tree is going to be for actually when you're moving. And we'll set the threshold fairly low on this one, so if you are actually moving at all, it's going to gonna bump. So the range normally runs 0 to 1, but or negative 1 to 1, but in our case we'll do it there. And in fact we might even do the magnitude of this one. The magnitude will be an absolute value from 0 to 1, just for reference, whereas the vertical will run negative 1 to 1. So correct my earlier thing. Okay, so that's going to be the basics. So now when it's moving at all, forward or back, we're actually going to move into this blend tree. Now this blend tree is going to have 3 animations. It's going to have, at the very start, we're going to have the idle. Whoops, sorry, I have screwed this all up. I should have added motion fields instead of blend trees to that. So we add a motion field, and motion field. So we add idle is going to be at 0. We're going to have walk. In fact, we even need to go, we need to add more. We need to add 5. So I'll add a few more. So actually the first one should be walk back. The next one will be idle. Next one will be walk. Next one will be running. And finally one more motion field, which is running fast. I'm going to set the threshold for walk back to -0.1. Set that to 0. We'll set that to 0.2. We'll set that to 0.5, and we'll set running fast to 1. So that you can sort of see that's the transition points where it blends from one animation to another. You can see at this point there'll be a mix of 3 animations and so on. That's what that little chart is going to give you. So as we open up our animation preview and we hit play, you'll see that that's with the threshold set to -1. So that's be anything less than -1 will also trigger that. It'll clamp to that. I use my stream. Just give me 1 second. I will quickly make sure that my upload is off, and I will just restream the URL. Hopefully we didn't lose anyone. Just want to double check with my audience. I'll just post these URLs around. Sorry, 1 second. Okay, alright, so I'm going to presume everyone's back. Okay, so as I was saying, the input, the vertical speed, if it's -1 or lower, it'll walk backwards. If it's 0, it'll idle. If it's 0.2, it'll walk. As we get faster, it'll move into a running. So as it hits 0.5, it'll slowly transition between these values. So here it goes walk, whereas here it's sort of that awkward walk, run, jog, and then as it gets faster, it'll move into the running fast animation. So now you can see we've got the full range of animations covering our forward and back. Now you could do this with all sorts of animations, so we actually could do a 2D blend potentially, which would cover the left and right. And in fact, this may even be a better approach. I don't know if I can delete this while keeping this one. I have a horrible feeling I can't. So actually this is another approach, and I'll go through, we'll rebuild this one from scratch, but very quickly. For the left and right, we can actually do a full 2D blend. And to do that, I'm just going to delete these guys. So yes, and yes, and I'll set this to a 2D simple direction or freeform directional. So the 2 parameters here are going to be horizontal and vertical. We'll just add, we'll get to add 7 for this time. So we add 1, 2, 3, 4, 5, 6, 7. Sorry, freeform Cartesian. So there we are. Now we got the plane where we're going. So the first 2 we're going to put in is going to be strafe left and right. In fact, I may have even missed one, but let's make sure this is okay. So strafe left is going to be -1 on the x-axis, and it's going to be 0 on positive axis. That's going to be 1. So now we can see these 2 animations are now in these little curves here. And we did actually boost the speed on those before, so I'll do that same here. Next one we'll do is idle. Now idle is going to be sitting in the 0 range, so if you've got no animations pressed, then it'll be sort of sitting just there. Then finally we're going to add to 0 on the negative, because it's got no left-right influence. We can add to -0.1. This will be our walk back. Now it's 0, and we set this to 0.2. This is our walk. And then we've got run, which will be at 0.5. And finally, run fast, which will be 0 to 1. Okay. Alright, so this one should now be all sort of good to go. And then this one, if we play around with these again, we'll have two separate controls we can play with. And I'll just need to shrink this one across a little bit so we can see it. So we hit play. So that's at 0, 0. That's the horizontal is at 0, vertical is at 0. Now if we move left, it's going to shuffle left, move right. Now the good way of doing it in the 2D is that it'll actually blend across even more animation. So our left and right and our forward and back will be all blended together. So you can see here that if we move there and we go left and right, it's not terribly animated there. So what I may even consider doing, I'm going to add that to 1. I'm going to set the left and right speeds. I'm going to add 2 more animations in here. You can actually add the same motions again. So I'm just going to add the left and right, but I'm going to set the speeds up dramatically. So I'll set that to 5. It's probably going to be ludicrous, but 0 and 0, and we'll set this to 1 and 1. Oops, that should be -1, 1, 1. So see, as we select these, we can see the range of influence on what we've got, and the little red dot shows us where our current position is. So in this case, now as we walk fast, it will sort of shuffle along sideways. Now, there's degrees of influence and things we want to play with here on exactly how this is going to go. One of the things we might need to do is, again, add a couple more. We can just keep adding motions here. It's not terribly performance intensive. It's pretty optimized. We'll just add another run fast up nearby. And that way we can sort of control some of this influence. So we'll add that to -0.5 and 0.5. You can now sort of see that that's going to help us just control a little bit of the sideways movement. So as the horizontal, it's not going to be too bad, but so there we go. This is our 2D controller. Now you can do better controllers if you've got more animations that have got more sort of flexibility, but as you see, as I shift these around, these little dots will highlight and that'll actually show what's influencing what and what it's blending between. So it's blending between 3 animations there, it's blending between 4 animations on the cusp right there, but it'll all give you nice control. Okay, so this is the hard part of our animation controller almost done. So let's drop you back there, and we'll just go back to the base layer. Now, I mentioned before that we need to handle jumping, and we also need to handle flying. Now, flying, what we could consider doing is doing another blend tree, and you would do that consider over the top of these two. So this would be our lower node, and then we would consider adding an upper node which handled the blend for flying. But I'm just going to do a much more simple control here. So I'll just call this one, this is going to be our basic motion, because that controls all of our idles and all the base of it. So this is going to be our default. So I'll set that as the default state as well. Now, we've got a few more. So jumping. For jumping, it's a relatively straightforward thing. We just bring the animation in here by dragging it in. In this case, I've already got one. And then you select this one, right-click on it, hit make transition, and select the node you're going to transition to. Now, we've got to indicate why it's transitioning. Now, what you'll notice is that we've actually got a list of conditions here. And that can be is jumping. So we actually should have one for is jump. And if jumping is true, then we'll transition into this animation. So it'll go from there, transition, and go boing. Now we can remove the exit time from this, and that'll mean it'll transition as soon as the condition is true, rather than waiting for the current animation to finish whatever loop it's on before doing it. So we can actually also set some of these back a little bit. So we're just going to try and keep it fluid. Really as fluid as possible. So now we can sort of preview how that's going to happen. So that's a pretty quick jump. Now that's probably going to jump back as soon as it's done. So what we can do is we can just do a make transition here. And we'll just set the condition to false. So now it'll transition back whenever there's no exit time. So let's go for this jump, and we'll set that to false. We'll set that exit time there, so it actually has to complete the jump animation before transitioning back to the idle. and that covers our basic jumping thing. Now for flying, similar process, except what we'll do is we'll just go another blend tree. So this will be our fly tree, and we'll do this one, we'll transition between these two blend trees if flying is true. So again, add a condition, and there should be one for is flying. Now if it's flying, it transitions there. We'll set a transition back when flying is no longer true. So that's fault. And we'll just remove the exit times from these ones. They should be sort of instantaneous transitions. Now, if you've actually got transition animations, you can sort of chain between two of these. So you could go from here to here to here to include sort of a start flying, stop at flying animation, that kind of thing. In our case, we're not going to bother. This is going to be a very basic controller. Okay, so we've got the basics up there. The fly tree is just about ready to set up. So this one, we're just going to control off fly vertical, so it's just going to be a 1D control. We could do it as a 2D control with sort of the forward and back movements, which is probably what you should do. In our case, we're not. We're just going to be a little bit cheap here because we don't have any flying animations to start with. So I'm just going to do change this one to the fly vertical, and this is the up and down keys. So basically, when you hit E or C or page up, page down, it'll control into this parameter again. -1 to 1 is the range. So I'll just set the range to, we will run fast if we're going to fly down, we'll roar if we're going to fly up, and we'll idle in the middle. Again, we don't have any actual animations for this controller, so we can't really do much about it, but we'll just set this one to -0.1, 0 to 0.1, and that's because it caps, so we want the thing to quickly transition into these states. Okay, so that's our fly tree. Now, there is other animations we can, other controls we got in here potentially you can play with. Like there's the input angle of the floor, so you can actually have feet tilt up and down in your animations if you've got enough blends and things to handle that. There's all sorts of other little controllers on the side that can get triggered in certain conditions. Like for instance, if you are falling, there is an is fall, which means you can have things like splat animations when you land. So what you can consider doing is doing something like this. So we can create I believe we've got a death animation in here somewhere I saw. So that's what's going to happen when we crash on the ground. So what we can do is we can just create a new state. And we're just going to do this as a two-stage. We need a falling animation. I don't know what we've got in the way of falling animations. Probably not in the way of much, but we use that as our falling animation. Again, we don't have a lot of animations, but it'll do the job. So I've got that one, and then finally we'll have the death animation when you hit the ground. So we'll transition from here into our falling animation when is falling is true. And then what we'll do is we'll actually have it transition to here when is falling is back to false. That means that it's been true at least once, and now it's false again. That means we know that its player was falling, and now they're not. And in that case, we've now got the transitions. We just transition out of here automatically. And this way, when you start falling, it'll transition into the falling animation. Then when you hit the ground, it'll play that animation, and then finally it'll transition back to the normal controller. So you'll see it'll get back up. Very straightforward. Now you can play with the lengths of the blends here a little bit if you want to make them a little bit smoother on exactly how long it takes an animation to come back up. You can play with these transitions, and I do recommend it if you want to make things look good. You've got a lot of controllers and animator over exactly how and when transitions happen. But this state tree will do. So we now have our tiger controller. We have our tiger. We are pretty much ready to set this up as a costume item, which is good timing because we're about halfway through now. So the first thing we do is we just create an empty game object. We add our clothing item settings and our virtual good. Now we're going to grab our skeletons. It doesn't actually matter too much anymore. We have made that change very recently that skeletons no longer matter, but I have not updated my editor pack, so unfortunately I can't push this one up just yet, but we'll call this one female. This one is a costume, so it ticks the costume slot. You should tick all the other slots as well when you've got a costume, so it's a little bit of a pain, I know, but this basically just stops the costume being worn when anything else is, which can cause problems if the stuff isn't compatible with it. At some point in the future, we will probably enable the ability to have accessories on top of costumes in the long term, but I think that in the meantime, it's not necessarily the best way of doing things. And we will tick the animator slot because we will have an animator for this. So, It's got a custom skeleton, and the reference prefab is this guy. So we're just going to turn this into a prefab, and to do that, it's pretty straightforward. We just drag that into there, into your project folder. This turns it into a prefab. Now, there's one important thing. When you do custom animators like this, you need to untick apply root motion. If you do not untick that one, your avatar will walk off, and your camera will not follow. So you need to untick that one. Our own locomotion systems do conflict with this, so just leave it unticked. That'll be available to untick as soon as you dragged it back into the project. So we'll just call this one Tiger Avatar 2. Okay, so we've got that one. Now let's grab our game object. I'm going to drag that Tiger Avatar from the project panel into the root template. Finally, the next thing we need to do is set up the controller. To do that, we just got the custom animations, and we've got the Tiger controllers. We just drag that one in. Now, we just need to set the names of all these properties. So in this case, we just need to go, okay, the magnitude property is called input magnitude. Now, these can match to whatever your controller is, so if you've got a controller already set up, you can just change the names to whatever your one actually is. Most of them tend to be pretty much the same. So input angle, vertical, horizontal, fly vertical. Also, just something to note, if your it's floor angle here. If your animation controller does not have one of these input parameters, you need to fill it in regardless. So you need to add a blank parameter onto your controller that it can pipe values into. If you do not, your costume would be rejected by reviewers, and also it'll throw a bunch of errors. So you do need to have these parameters even if you're not using them. It is optional to use them, but it is mandatory to have them. So to set the floor angle. It's a tiger. Set all these values. I'm not going to actually push this to live server, so I won't include the images for now. The asset store. I forget the exact name of the developer of this one, but it is available in the asset store. Just push that all through. And now we just drag this Tiger Avatar. Whoop, we need a new name for this one. So let's try Tiger Avatar upload. Let's drag this into our folder. Select it, and we are good to go. So I will submit this later, but for now, I want to move on to my next topic of the day. And that is how we handle bringing in costume avatars that can still work with the plain rigging and clothing systems. Now, I have not had a good chance to properly play around with this. This is something that we're sort of experimenting with. But what this, in theory, should do is let you bring in sort of fully custom skins and elements and things and still use them without clothing fitting systems, and also be able to resize the avatar based on how the user does it. Now, the trick to doing this one is basically mirroring our base avatar. So what I'm going to do is I'm just going to go, I placed a bunch of them in the scene earlier, which I'm going to go find. So I have a model which has become out of Fuse. Now, Fuse is a basic character building system that Adobe publishes. It used to be produced by a company called Mixamo, and it basically just lets you build characters using sort of piecemeal bits and pieces, like you grab an arm from here, arm from there, that kind of thing, and push it all together. And then you can sort of size and shape as appropriate. Now, Fuse is not necessarily, I do have to sort of recommend a little bit against using Fuse here, just because these avatars do come in with a few problems on them. There's issues with the materials. They tend to sort of do this, and that's because they come in with transparency set when they shouldn't. So if you actually send the rendering mode back to opaque, you can get these back to normal, but you sort of have to fix these one by one, and there's a couple of problems with them. So that's one thing to watch out for. And the second thing that you've got to watch out for is that because people have been bringing them in as costumes, they don't sort of work with all the user experience things that people normally expect to work, like being able to wear clothes, being able to resize and reshape the avatar. Now, what we're going to do today is we're actually going to look at bringing this in as an item of clothing, and both by bringing it in as an item of clothing, we actually have a fair degree of power over exactly how the shape will get morphed by our body sliders. So if you've got a slider that makes the character overweight, then in theory we should be able to modify these avatars as well. The key to that is going to be form fitting. Our clothing resizing system basically works on I guess what we call it as a vector field system, where it sort of builds a flow map of how clothing reacts when certain body shapes and things are modified. And the best way to get these characters to work with that system is to have them as close as possible to our original model. So if I bring this one in from Fuse, I've uploaded and downloaded this one from Mixamo, you'll see that the basic model as it comes in is a little bit too large, but we can fix this. The other thing we need to do as well is just as prep work. This model isn't affected by this because I set it up this way, but when you're doing a kick model this way, it needs to have a single mesh. Now that mesh can have multiple materials, but it needs to come through with just one skinned mesh renderer. This one actually has a couple. It has the eyes and a few other bits on separate meshes. For the purposes of today, I'm going to ignore those, but when you do this work, you will need to make sure those are merged all in together, so that it's just one skinned mesh renderer with all the vertices and things attached with however many materials as you like. The number of materials doesn't matter so much. Now, when we bring this one in, as you can see here, it's a little bit too large for the player. So what it is, because this one's skinned and rigged, we can actually sort of play around with the bones, and this is how we're going to get this one to fit and match our own avatar. And to do that, we just go through the rig. We can go to the spine node, for instance. We'll shrink this one a little bit. So I'm just going to grab the scale tool. I'll bring this one down, and we will try and get this to as close as possible. Okay, so that's looking like a good starting point. We'll grab the spine too, and we'll just move this a bit forward. We just need to get the character, roughly speaking, matching what we've got. So we'll just keep going through these parameters until we get this right. So I might shrink this neck node a little bit until our head matches, and we'll move the head back a fraction. Okay, the more we've got the sort of the grey and the original skeleton visible at once, probably the better. My guess is that that'll line up as better. The more precise we get it, the better it's going to be as the end result, basically. So we'll just keep going through here. We'll go through the shoulders and the neck. So we'll just grab those two, and we will play around with them. And eventually, if we poke around with this enough, we should be able to get the basics of our model lined up. Now we're going to have to go through quite a few sort of tiny little fiddly bits here, which I'm probably not going to go to too much detail on, but I'm just going to try and get the basics running. So we'll try and line up the fingers as well. This is probably going to be a bit more of a pain in the ass than it sounds like, but it's not too bad actually, all things considered. We just need to plug these guys together. As I said, the closer we can get this to match with the base skeleton, the better it's going to be. So, the forearms. Now, when you do this for Mixamo in particular, because the avatars all have the same rig, you could probably actually just copy these settings once you've figured it out the first time. Hopefully can avoid this looking too abnormal. Try and get this right. This will take just a second. There'll be some rotation magic in a second to actually try and get this all to behave. So we'll grab the pinky, and hopefully the pinky between the two of them is mirrored. I believe it is. Great. So it's also local. And now, if we're lucky, this is on the opposite of what I wanted. Damn it. Okay, so we'll grab these one by one. I won't bother with the feet quite as much. I just want to go through this process one by one. Again, we just want to try and line this up so we get as much of the grey visible as possible. So the more overlap you can get on these, the better it's all going to behave. I need to go back to primary school because I can't remember exactly which finger is which. Okay, finally a bit of fun. Okay, and hopefully we haven't made a horrible mutant monster. No, that still looks kind of natural. Okay, alright, we'll progress with the other arm. I swear this one actually might, this hand feels a bit off actually. I don't know if there's something wrong with it, but I'll just move some of the stuff around. Obviously, we want to try and keep this symmetrical if we can. Now the reason we're doing this in here in Unity is because we actually, one, we can play around with this and line everything up correctly, and two, we can export it using our clothing tools. We can actually sort of use a feature on them in a way that wasn't quite intended in order to output the mesh in the way that we want. So finally, we're just about done. So we've got that, and move him out. Okay, so this, fingers crossed, should be a pretty good job. Yep. Alright. As I said, I won't do the feet, but ideally the closer we've got this matching, the better it's going to behave. So, we've grabbed this mesh renderer, and we're going to grab the base skin mesh renderer we've got here, and we're going to add a clothing item settings. This is only temporary. We're not actually setting this up as a clothing item, so you can ignore all of these, but you can go down to one magic button, which is convert to reweighting. And when this does this, it'll delete all the skinning information. And we lost that. Okay. This might be a problematic method. As I said, we haven't tried this before, so we're hopefully not losing everything here. I might need to bring this guy back in. I apologise. Sorry, we're going to have to sort of redo a second's work. It feels like I've done something stupid. Which I have, but I feel like I've done something even stupider than usual. Let's grab that body. I said the body model backward, probably. No, we do appear to have lost it. Okay, so I apologise, we're going to redo this very, very quickly, but hopefully it won't take us very long, so we know exactly what we're doing. I'll not do quite as good a job on the hands this time, but let's have a look here. Okay, so we grab the spine, we scale the spine down a little bit. So we're going to have to use another technique for bringing this out, but what we can do is we can just export the mesh, and we'll just need to write a little bit of a quick script to do this, and I'll pass the script out at the end of the tutorial. So I'm just going to grab him, move him a little bit forward, keep going here, neck, head, etc. It's a bit of a shame. I thought I actually did a half decent job that time. Okay. The more we can get stuff to line up, the better. So if we can get the ears and all that stuff to sort of fit together, the better this will work. As I said, the closer it looks, the better. Okay, finally, left shoulder, left arm, left shoulder. Actually, left shoulder, left shoulder. Let's grab. re-implementation of what we just did. Getting quite good at this now. Yeah. Almost done here. Alright, we brought him along. Now we're going to need a quick script just to bake this skin mesh renderer. That's going to basically take the data we've got with all the various modifications we've made, and we're going to basically export this to not an OBJ. We're going to export it to what's called an asset, and the asset will contain everything we need. So we're just going to add a quick script, and it's going to be called bake rig. It'll be very, very, very basic. It's going to take 1 second. Okay, so this guy we are going to just add a public static method. So we're going to learn a little bit of coding too. Let's add a new menu item to the editor. This is going to be so menu item. Export avatar to file. This one's going to go selection.activeObject.getComponent skin mesh renderer. Let's grab bar mesh equals mesh renderer.bake, which we need to do. Just going to save the mesh as it is into a file. We're just going to quickly do this, and I'll hand this script out later. But for the second, click that. Just create assets based on the mesh, and we'll call this one saved avatar.asset. Refresh. Okay, that should do the job. So, assets to file. Give it a second to compile, and hopefully we've got a new menu option when we've got this selected. So I just grab this one's. What did I call it? Oops. Give it a name. Okay. Good luck. This. Now I got it in here. So we've got tools, export avatar to file. And it's, because we forgot to put it into there. Live debugging. Okay. Okay, now if you look in the assets directory, we should have a new saved avatar. And lo and behold, this is our avatar. As you can see here. Nothing particularly special about it, but if we grab that skin, go onto there, we have got our basic avatar. We've got it out of the fuse rig. It's not skinned anymore. We can just bring this into 0, 0, 0, and it lines up basically as we expect it to. Maybe not perfect, but that will do the job. As I said, I'll paste that script out there, but it's not terribly complicated. It's just getting active skin mesh renderer and saving it, and then bringing it back out. Okay, so this guy can now actually be set up as a clothing item. So, first things first, we add a clothing item settings, which is the basic of all of our clothing. So we'll grab this to the base male. We probably won't tick anything. We'll tick the skin base because that's probably the most appropriate. And this will be underwear. No obscuration distance. We'll skip deletion. Actually, we won't skip deletion, but we will add a deletion zone to this one. That's the first thing we're going to do. Is going to big deletion zone, and that's just because we want to wipe out the base avatar. So that will just go. Boom. This is probably a bit overkill, but at least I know it'll work. Okay, so that will guarantee you to wipe out whatever was on the avatar underneath this layer. So the first things first, it doesn't have a custom controller, it doesn't have a custom skeleton. We just need to sort of set this one to convert to weighted. So that's the first thing we'll do. I'll just save this, convert to skin. It's all lined up as it should be. For a moment. Take a minute. Obviously, the more it's wrapping, the longer it takes to actually do the skin weighting. Okay, here we go. Now it is rigged again, and it's rigged against our skeleton, and it should have all the deletion information pretty much there. We just need to do a preparation and an upload. So for this one, we'll just do the virtual good. Again, categories, clothes, body. We'll call this one a skin. Actually, it's kind of fits into that category. So this would replace the basics of an avatar, as you would like. Okay, final thing we just need to do, we'll just prepare it. And this will just take a second. It will take longer than usual when it's preparing this, just because it's going to cover so much of the base body. The more of the base body a clothing item covers, the longer this step will take. Hopefully it won't take too much longer though. Usually the process is pretty quick. We've actually done some big speed ups here in one of the future editor packs that's about to come out that'll actually speed this up by a factor of, I think, about 90%. So just useful, less time sitting in front of progress bars when you're actually doing these kinds of things. This is actually just pre-computing a lot of the stuff that the viewer uses for things like our body shape sliders and things. We actually calculate as much as we can in advance on the editor. And that's just because it means less lag in the viewer. So while we push some work onto your computer here, it then gets taken advantage of when the client loads it all up. Our processing servers will actually do a bunch more on top of this. It'll do actually quite a lot more of some heavier calculations at the time. So hopefully it won't take too much longer, but this is basically everything we need done. So when we upload this guy, it should come through with the replacement for the skin, and it'll still allow you to use the basics of a third-party avatar while still taking advantage of a lot of our features. Now there's a few things I'd probably note as a downside to this technique. The first is that the avatars will load slower. That is because things like our skin deletion that is baked into our clothing, we actually pre-compute it for interactions with the base skeleton. And as a result of that, it means it can load quickly and delete skin, whereas here it's actually going to have to calculate by scratch every time the viewer loads up the avatar, because it's not going to be able to pre-compute against every single clothing item that exists. That's the first downside. Second downside is you're going to lose some customization here. There is no way that all this is going to line up with everything else that's in the viewer. You will lose things like the ability to have lip sync with voice. You will lose things like the ability to use our new facial capture features. There will be downsides to doing things this way, actually probably pretty serious downsides, but I'm hoping at least by showing this technique we can make some of the people using costume avatars get a little bit of a better underlying avatar with their characters, because at least doing it this way you can wear clothing, so it'll still let you interact with the clothing system, and it'll still let you interact with quite a few other basic systems that we've got in place in space, and hopefully again this won't take too much longer. Usually it sort of finishes by now, but this is going to be a big one. As you can see, it's sort of calculated, I don't know, is that 33 billion calculations and counting. We'll take a minute to chew through what it needs to do, but we'll take a moment. Finally, I'd say that you're also going to have limitations on things like being able to wear user skins and those kinds of things. So what you're doing here is you are restricting your avatars quite considerably by using this technique. So it's not the one I'd absolutely recommend that everyone does, but I know there are people who need the use case, who are interested in how it goes. Aha, okay, so we have got we should have our character. Just take 1 second. Need to come back to normal. it'll still take a minute. As I said, the more it covers, the longer it's going to type and also take us. Also, the higher the poly count. I'm not quite sure what the poly count is on this model, but I'm sure it's considerably higher than the default recommendation. Speaking of which, I don't really have them on hand, but we have the new character models, which I've talked about in my office hours, which are considerably higher polygon. They are just around the corner. They are almost complete. I've got the test versions to play with at the moment. We're just looking for bugs in the skinning and a few other things, and once we're actually done with those, they'll be good to go and ready to go out. And hopefully this will only take a second longer, and I can actually get a quick upload going while we've got office hours today. Other than that, though, we are actually done at this point. There's nothing special we need to do with this this avatar. It is actually ready to go. So it takes more than another minute or two. I'll probably just finish the recording. We can show the upload show the progress from in a future tutorial. The other thing I wanted to cover today, which I didn't quite get a chance, was attaching animated and skinned attachments to an existing humanoid. So if you have things like tails, ears, all those kinds of things that you want to sort of attach onto the base skeleton, using the attachment system is a great way to go, because you can actually load in as location with the redesign. So we've got all sorts of things to talk about, and I look forward to seeing you all in World in a minute. Alright, fantastic. Bye.